In some layers of rock in China, the boundary is a few centimeters thick. Below it, a rich, complex fossil record. Trilobites, reef builders, ancient fish, creatures that had survived nearly 300 million years of everything this planet could throw at them. Above it, almost nothing. Geologists call it the gap. A stretch of rock where life essentially stops being recorded. Not because nothing was alive, because almost nothing was. This is the Permian-Triassic boundary, 252 million years ago. And the thing that created that gap wasn't an asteroid. It wasn't a comet. It was heat. And a chain of events that heat set in motion, each one making the next one worse, until the planet's own chemistry turned against almost everything living on it. 90% of marine species gone. 70% of land vertebrates gone. Scientists don't call it an extinction event. They call it the Great Dying. The asteroid was a one-time event. What happened here was a mechanism. And mechanisms can repeat. 252 million years ago, there was no Atlantic Ocean. No Pacific in any shape you'd recognize. Almost every landmass on Earth was fused into one supercontinent, Pangaea, wrapped around a single world ocean called Panthalassa. The dominant land animals weren't dinosaurs. They were synapsids, mammal-like reptiles, some the size of hippos, ruling ecosystems tens of millions of years before a single dinosaur existed. The oceans were just as rich. Ancient reef builders and trilobites that had already outlasted nearly 300 million years of prior history. This biosphere had survived ice ages, sea level swings, and smaller extinction pulses. There was no impact crater. No fireball from above. The apocalypse came up from underground, and then it fed itself. The lava wasn't the killer, the gas was. In what's now Siberia, the Earth's crust split open and stayed open for close to 2 million years. The basalt it left behind is over 4 kilometers thick in places, covering an area larger than the continental United States. This is the Siberian Traps, one of the largest volcanic events in the planet's 4.5 billion year history. But the eruptions themselves weren't what ended the Permian. The magma burned straight through vast underground coal deposits on its way to the surface, releasing carbon dioxide and methane directly into the atmosphere, on top of what the eruptions were already producing. Tens of thousands of gigatons of carbon, released in pulses too fast for the planet's natural systems to absorb. And this is where the story stops being about one bad volcano and starts being about a chain reaction the planet couldn't switch off. Carbon dioxide traps heat. Global temperatures rose an estimated 5 to 10 degrees Celsius. A fire in a fireplace is the same chemistry as a wildfire. Same fuel, same oxygen, same reaction. The difference is whether the fire finds a way to keep making its own fuel. The Permian greenhouse effect found that way. As oceans absorbed the excess carbon dioxide, they acidified. Marine life that built shells out of calcium carbonate found the ocean chemistry turning hostile to the basic act of forming a skeleton. Reef systems collapsed so completely they vanish from the fossil record for the next 10 million years. Warmer oceans also hold less oxygen. Large sections of the world ocean turned anoxic. Dead zones uninhabitable to almost anything that needed to breathe. Then the mechanism that made it a runaway. As the deep ocean warmed, frozen methane deposits on the seafloor began to destabilize, releasing an even more potent greenhouse gas into an atmosphere already failing to cope with the first one. Whether this happened in one pulse or several is still debated. That it happened is not. Heat breaks ocean chemistry. Broken ocean chemistry releases more greenhouse gas. More gas causes more heat. Each stage making the next one worse, each stage harder to reverse. This is what a runaway greenhouse effect actually looks like, not a gradual warming trend, but a feedback loop that the planet's own systems start driving. The Permian is the only place in the rock record where we can see it run to completion. An estimated 90% of all marine species were wiped out. Not 90% of individuals, 90% of entire species, gone from the fossil record permanently. Survival wasn't random. Organisms that made it through tended to share specific traits. Tolerance for heat, tolerance for low oxygen, and the ability to burrow. Animals that could retreat underground during the worst of the heat and toxic atmosphere had a real, measurable survival advantage. Some paleontologists point to burrowing behavior as one of the clearest predictors of which lineages crossed into the next era and which didn't. A creature's odds of surviving the Great Dying may have come down to something as simple as whether it could dig. Trilobites, after roughly 270 million years of surviving everything else, disappear completely. On land, around 70% of vertebrate species were lost, including most of the dominant synapsids that had ruled Pangaea. Even plant life took a hit, unlike almost anything else in the fossil record. There's a stretch of roughly 10 million years afterward where almost no coal deposits form anywhere on Earth. This was sometimes referred to as the coal gap, because the forests that produce coal had been wiped out too thoroughly to leave anything behind. 10 million years is long enough to replay the entire existence of Homo sapiens more than 30 times over. And that's how long it took the planet just to grow trees again. Recovery from a normal extinction takes a few million years. This one took nearly 10. Most extinctions show a familiar recovery curve. Diversity craters, then climbs back within 1 to 5 million years. The Permian-Triassic boundary breaks that pattern. For millions of years afterward, ecosystems stay strange. Simplified, low-diversity communities that researchers sometimes call disaster faunas, nothing like the rich biosphere that came before. Elevated carbon dioxide and unstable ocean chemistry persisted well into the following era, with evidence of at least one, possibly several, secondary warming pulses. The climate system stuttering rather than resetting. For nearly 10 million years, the fossil record shows the same thing everywhere you look, a biosphere running on whatever survived. Not recovering, just persisting. The unsettling part isn't the scale, it's the physics. Heat, carbon, ocean chemistry, all behaving exactly the way basic science says they should. The scale was extraordinary. The mechanism wasn't. The next event in this series ran the opposite direction. Same planet, same basic physics. But instead of heat running away from itself, the cold did. And it nearly ended things just as completely.